Alright, we can make a similar plot in MATLAB. So we have mass, spring. These are the different values of damping we have. These are the range of omegas. Lin space is linearly spaced points between 0 and 20. And then since we want to plot it using both variations in C's and omegas, basically we want to use a mesh grid, which basically has various values of C for each value of omega. I have a semicolon off. You'd want a semicolon after anything big like C. Normally you'd want that. And then basically here we're calculating x over y. It's a square root of k squared plus C dot times. So basically these are, you want this to do a component by component rather than a matrix operation. So use a dot times, and then dot squared, dot divided by. Again, it's the first value of k times the first value of C times the first value of omega. This does all the loops rather than having to write loops for each one. It's basically doing all of the calculations all at once. So that's MATLAB is quite powerful in this. So it's dot caret, dot caret, dot caret. The square root will do individually ones as well. Put it on figure 1, plot your omegas versus your x over y, and then the legend is a C transpose, and what that does is basically makes it, rather than a row of C's, it's a column of C's, and it's num2 string basically. C's numbers, and you could just do make your legend into a string array is the other option. So we're going to run it, and then magically pops up our plot. So in our plot we have going from 0 to 20 and basically different values of peak, and so we can see where you are underdamped considerably. If you want a little higher resolution on Lin space, you can change the number of points to say 1,000. Run it again, and now we have a much smoother curve. In general, your car should be driving past resonance, and so this should be far to the left, and then in general we're going to be operating faster than the resonant frequency of the car. But this is how you can use the dot. And then just looking at it, so basically these are your different values of omega. So for each value of C horizontally, you're going to have a value of omega, and then your C's are going to be every row is the same. With the mesh grid, for the C's, every row is the same. For the omegas, every column is going to be the same. That's how mesh grid works. So that's how you can do calculations quickly in MATLAB.